we are going to discuss few past year test 2 problem. Okay, it is on page 11 in your lecture notes. Okay, so I'll start with problem number 2. We have Laplace of 3 sine t cos t. Okay, look at A. So for this one, okay, so in the bracket you can see you have actually two terms, sine t and cos t. Okay, so the common mistake, okay, what a student did previously, so some of the student will do this. Laplace of 3 sine t cos t, so they put aside the 3 because of the linearity property, this is right, and then they tend to write the Laplace of sine t times the Laplace of cos t. And they will solve individually the Laplace of sine t. So by referring to this table, it is 1 over s squared plus 1 squared. And the Laplace of cos t is s over s squared plus 1 squared. So this is not right, okay? Because if you have two functions, okay, in terms of multiplication, you cannot separate into two multiplications. Okay, it cannot be unless you have plus or minus. Okay, if you have sine t minus cos 2t, for example, then yes, you can separate into two Laplace transform, Laplace of sine t minus Laplace of cos t. But if you have division or multiplication, then it cannot be simply, okay, Laplace of the first function times the Laplace of the second function. Okay, so it cannot be done this way. So this is not the right step to do. Okay, so what do we need to do here? So if we refer to the table, there are no such thing like sine t times cos t in the table. On the left hand side here, we don't have again a Laplace in that form, but individually you have cos and you have sine. Okay, so we need to think of how can we manipulate the expression here, the 3 sine t cos t here, to be in terms of maybe sine t only, sine at only, or in terms of cos at only. Okay, so the idea is to have, okay, the individual cos at or sine at. Okay, so we need to refer to the identity, okay, identity of trigonometric function. Okay, so in the exam, you also will be given this formula. Okay, the list of formula here. So we can see the one that is related to our problem is here, this one. Sine 2t equals, sine 2x equals 2 sine x cos x. Okay, so but we need to change accordingly, okay, our variable. Okay, so from the identity, okay, so we know that sine 2t equals 2 sine t cos t. Okay, and if we refer to our problem, this is actually what we want to rewrite. Okay, so now the Laplace of 3 sine t cos t can be written as, I can put aside the 3. So inside we have the Laplace of sine t cos t, which can be written as 3 Laplace of, by the identity, it is sine 2t over 2. So 1 over 2 again is a constant. You can put aside together with a 3. So we have 3 over 2 Laplace of sine 2t. So now, okay, we can refer to our table, Laplace table, where we have sine at, which is a over s squared plus a squared. So in our case, a is 2. So it is 2 over s squared plus 2 squared, which is 4. And at the end, okay, we can simplify 2 and 2. So we'll have 3 over s squared plus 4. Okay, so that's the first one. Very simple. Okay, provided we know how to manipulate the expression 3 sine t cos t. Okay, Now, for b, okay, we have the Laplace of exponent 2t, t minus 1 square. All right. So, again, okay, first of all, you need to refer to the table, okay, because we want to map to which one, all right? So we have exponent function times t minus 1 square, okay? So we have two terms, all right? So we have to refer to this, okay? So we have a function exponent at times some function ft. So we are actually in this form, okay, similar to this one. So this one is mapped to the Laplace of exponent ATFT, which is the answer supposed to be in the form of Fs minus A. So this is the first shifting property that we have discussed earlier. Alright, so this one, now if we map, then we know our A is 2 because we map exponent 2t with the exponent at, so that we know our A is 2. And then the ft is t minus 1 square. Alright, so from the ft, we find the fs. Okay, because our intention is to know what is the Fs minus A. So if we know what is Fs, then we can find for whatever S plus A or S minus A. Okay, so we need to get the Fs first. So Fs is the Laplace transform to the Ft, okay, which is the Laplace to the t minus 1 square. Okay, so now, okay, we want to find the solution based on our table. Okay, so if we refer to the table, here, we don't have t minus 1 square. Okay, t minus 1 square, we cannot. Okay, we don't have that. Okay, we have t power of n alone. Okay, but in our case, we have a t minus 1. And then, okay, outside we have power of 2. And somewhere here we also have t power of n, but it is multiplied to some function ft. Okay, so directly from the table we cannot get the solution. Okay, but we know that t minus 1 square can be expanded. Okay, can be expanded to be, so this one is actually t square, okay, minus 2t plus 1. Alright, so and then we know by the linearity property, so we know that this one can be written in the form of Laplace of t square minus Laplace of 2t. Okay, but again, you can put aside the 2, so minus 2 Laplace of t plus Laplace of 1. So you can see individually, you have those three terms in the table. Okay, so it is now based on the table Laplace of t square. So if we refer to the table, we have t power of n here. So in our case, n is 2. So the answer is 2 factorial over s power of 2 plus 1. Okay, so we have here 2 factorial, which is 2 over s 2 plus 1. Okay, and for the t, also we refer to the same thing in the table. Okay, t power of n, our n is 1. Okay, so we have 1 factorial over s 1 plus 1. Okay, so we have 1 factorial over s 1 plus 1 here, and then Laplace of 1 is a constant. Okay, so in the table you need to refer to the first row. Okay, Laplace of k is k over s. Okay, so since our k is 1, so the answer is 1 over s. So here the answer we can simplify as 2 over s cubed minus 2 over s square plus 1 over s. Okay, but this is not yet our final answer because the answer is supposed to be in the form of Fs minus A. Alright, so go back to this one. So therefore, the Laplace of what we want to get, exponent to t minus 1 square, is actually f s minus a. Our a is 2, so fs minus 2. But we cannot stop here. Okay, we need to write what is the expression for the fs minus 2. Okay, so since we know that fs is this one, so this is fs. Okay, this one, fs equal to this, so fs minus 2 is basically you just substitute s, okay, with a s minus 2. Okay, so we have 2 over s cubed now becomes s minus 2 cubed. Okay, minus 2 over s square becomes s minus 2 square plus 1 over s becomes 1 over s minus 2. So this is our final answer. So you don't really need to expand, okay, term in the bracket here, and same thing for this one. Okay, so just top up to this. Okay, so this is for B.